So this will be our object-oriented lab for Unity. So we've gone through a lecture and we learned a little bit about object-oriented programming as a paradigm, and now let's look at it in practice. And in practice, it's actually very important in Unity because everything in Unity is an object. So right now we're in Unity and we're just using the same thing that we used for the last two of our labs. So this is exactly where we left off at the end of the functions lab. So we've got the function script and the variable script down here attached to a cube, and that's pretty much all there is to it. Now we can look at this from a slightly different perspective. Now that we know a little bit about objects, we can start looking at how objects work in Unity. So in Unity, pretty much everything that you put into the hierarchy is an object. In fact, it's a special kind of object called a game object. The game object is really the heart and soul of Unity and Unity programming in general. So we can see the fact that everything is an object by simply selecting anything in the hierarchy. Right now I have the cube selected, this cube that right here on this in the middle of the screen, and we can see that it has a number of things on it. And so we talked about inheritance and base classes, and the base class for pretty much everything in Unity is game object. Game object gives us a set of properties. In fact, it gives us this set of properties right here, the transform. So every game object in Unity, you can count on it having a transform. A transform has three pieces of information in it: the position, the rotation, and the scale. So that's always going to be present on every game object. And then beyond that, we have specializations. So in this case, the cube is a piece of geometry. Naturally, since it's a game object, it will have the transform, as just discussed. It will also have two other things since it's geometry. It will have a mesh filter and a mesh renderer. You get those automatically when you create any sort of visible object in Unity. So these are properties, extra properties that are going to be added just to the geometry in Unity. So you can see we have specialization. We start off with something basic, namely a game object, and then we add to that. And then we can keep adding things to that. So when we created our cube, we also automatically got a box collider. It isn't necessary for this to be here if we're not going to be using collisions, but Unity sort of assumes that this is the most widely used set of things. And so it gives you the mesh filter, the mesh renderer, which you have to have in order to see the cube, but it also goes ahead and gives you this box collider. You can take things off if you don't need them. You can select this little gear here and select remove component, and it will no longer have a collider on it any longer. And then, of course, earlier we added our function script. If we wanted to remove that again, we could simply remove that particular component. Now, these game objects in Unity can have more than one thing on them. For example, we can put our function script and our variable script on there at the same time. So it's possible to have multiple scripts attached to a single object. In fact, it's common to have multiple scripts attached to a single object. So there are a couple of ways you can do this. You can add using the add component, as we did before, and you can find the scripts that you've already written, and you can attach the scripts that way. The other way that you can do it very easily, I'm going to go ahead and remove this so we can add it a different way, is to just grab them in the assets, and you can drag and drop them directly onto the cube. And then I'll select the cube again, and you'll see that our variable script and our function script are both on there. Once again, you can remove them, and it's very easy to add and remove components. So everything boils down to adding components to objects in Unity. And now you're starting to see the problem with teaching object-oriented programming. The word object is a very non-specific word. So when I say object, I may be talking about something just in the Unity hierarchy, but I also may be talking about a programming object. So I'm going to try to keep those straight semantically as I describe what's going on. But you just have to sort of figure out how to parse what I'm talking about, or when anybody's talking about when they say the word object. All right, so we've been dealing with the cube here in the hierarchy. Just as a nice diversion, let's click on some of the other things we have here. We have a light and a camera, which we got when we created the scene. When I click on the light, you can see since it comes from the game object, as everything in Unity does, it has the transform, it has the position, the rotation, and the scale. And then beyond that, it has a specialization, a set of properties that are unique to that particular object, that particular light. And so it has the color, it has baking parameters, what kind of light it is, the intensity, bounce intensity, and so forth. So all of these things are going to be unique just to the light. And then let's switch over to the camera, and we can see again that we have specializations just for the camera. But as always, we have the transform because, again, this is at its heart and soul a game object. Everything starts with that as its most basic base type. So the transform is there, and then beyond that, we have all these extra things that are on our camera. So really what we have are all these things in Unity that are just built out of components, that are built out of objects. And so they start off as a game object, which is the base, and then you just add things onto it in order to get whatever it is that you're trying to make. This is an extremely important concept in Unity because later on we're going to be trying to address different objects independently of one another, and then we're also going to be getting the specific components on a game object and causing them to do things. For example, we might want our score display on our heads-up display or our user interface to change. Or we might want to change the color of our cube depending on the user's score or something that they just did. We want to be able to shoot objects out of guns, and we want to be able to jump over objects and have enemies attack you. And the only way to do all of these things is by understanding the relationship between what's in the hierarchy over here and then the different things, the different components that are on these game objects that you're creating in your hierarchy. So a very, very important concept. All right, so I'm going to go back to my cube, and we've got our functions and variable scripts. I have actually taken them off because I really want to show you something a little bit more interesting. So what we're going to do is we're going to actually do something with this cube. We're going to make a spinning cube out of this. We're going to actually affect something on the screen with code. So to do this, let's go and add a component. And in this case, we're going to create a new script from scratch. So there's lots of ways you can do this. Before, we did a right click and we did a create C# script. If I do it this way, though, if I click here on the cube and then I click add component, it saves me a step. So if I come over here and say create new script, make sure you've got C# as your language, and let's call this spinner, S-P-N-N-E-R. And when I click create and add, it saves me the step of having to add it to our cube. So it's just going to do it all in one step. I'll click create and add, and now we've got our spinner script here, and it has added it to the cube. And now I can just double click this to open it. And now that I've got my script open, I just need to add some code. Now we're going to have to cover what everything in here means a little bit later. For now, let's just see about getting some code in here so that we can kind of see how this whole environment works together. I'm going to add something on line 13, which is where the update method is. And we're going to add a little bit of code. It just says transform.rotate, and it's a big R. And then we're going to open parenthesis. We're going to say vector 3 dot up. And then we're going to say speed, which is something I haven't created yet. So it's going to, if it squiggly underlines, that's okay. We'll get to that in just a minute. Times 10F. All right, so what this is going to do is it's going to rotate our cube around the whatever up is. In this case, that's the Z-axis. And then we're going to be able to control the speed. Well, if we left this out, it would rotate extremely slowly. Let's just try, just so you can see what we're doing here, let's just try putting a number in here like, oh, I don't know, say 10. And I'll make sure that it knows that it's a float by putting an F on the end. And so let's just try this. I suspect that we will not like the results, but let's try it anyway. Let's switch back over to Unity and make sure we don't have any errors, and we don't. And let's go ahead and click play and see what happens. So it spins, but it kind of spins really fast. And so that, I guess inherently there's nothing really wrong with that. But one of the things that you would like to be able to do in Unity and in any game environment really is to allow people who are not coders a way of actually making this spin without having to come in here and change the code. And so when we're developing our scripts, it's a good idea to go ahead and expose properties which are editable. What do I mean by an editable property? Let's go look and see if we can find an editable property over here. Let's look at the light. When we look at the light, we have all of these nice little settings boxes over here. So we can change the intensity just by moving a slider. We can change bounce intensity. We can change color with this nice little color selection dialog box. And all of that is super nice. This lets somebody who is more artistically inclined and less programmerly inclined, if that's a word, to come in here and make changes to this. It also makes it easier for you just as a programmer to just have to come in here and flip a few switches, change a few dials, and punch in some numbers and see a different result rather than having to constantly come in here and change things. The other thing that you might want to take into consideration is what if you wanted to use this script on something else? So let's go ahead and make a change that will allow us to set this as a property. And we do this in Unity with access modifiers. An access modifier is something that allows outside classes or outside code to access the elements that are in this class. So we have a class here, it's called Spinner, and you'll note that it is the same as the file name. This is a requirement in Unity. It's not a requirement in C#, but it is a requirement in Unity. So this is one of the Unity specific things that you have to remember. The name of your file must exactly match the name of your class. And so that's very important. And the other thing that you need to bear in mind is that on the Mac, things are case sensitive. So a lowercase s on Spinner, an uppercase S in the file name might screw things up. It's more forgiving on the PC, but you should still pay careful attention to this because I can't guarantee that it's always going to work out for you if you mix up your cases. So usually when you do the create operation in Unity, it's going to go ahead and make the class for you and it's going to make sure that it matches. But if you were to come through here and change this to something else, then it's not going to work. Even though in C#, if you were developing a project in Visual Studio, you could come in here and change the name of the class as much as you'd like, and it wouldn't have to match the name of the file. In Unity, it's very important that it does. So watch out for that. That's a big gotcha. And so we have this class, as I was saying, and we're going to expose a property. And we do this with the public keyword. So I'm going to say public, and I'm going to call it, it's going to be a float. Most things in Unity turn out to be floats when they're numbers. That's just how it is. And we're going to make it speed. And just for grins, I can initialize it. I can set it equal to 10F. And now it has a default value of 10. And now I can come down here and I can change this to something else. So I can say whatever speed is. And that's perfect. So that's pretty good. Let's switch back over to Unity and see what that looks like. When I switch back over here, if everything goes well, when I click on Cube, I should see something get added to my Spinner script. And if it doesn't, then that usually means that I didn't save it. So let me go back over here and save it just to make sure. Switch back over to Unity. And I should see it appear as soon as it finds it. And there it is. So it takes a second, but it'll come up and it'll say speed. Now, since we put this assignment here, that's going to be the default value. That's going to appear here. And you note that it doesn't put the F in there. It just goes ahead and gives you 10. So what it will do is it will make some very sort of user-friendly looking labels for this. And it will allow you to set it very easily. So we've got the same thing happening now. If we run this, we're going to see our cube spin just as we did a moment ago. But now I can change this. I can change this to 100 if I would like to, and press that. And we should see it spin quite a bit faster. Or I can set this to something like 0.1 and slow it down to almost nothing. And so that's nice. I can change that. Now, this is another gotcha in Unity that you need to learn as quickly as possible and remember it always. I've been making these changes while the game is running. You can see the little blue up here that tells you that this game is running. And you can see that this is also blue. And what this is trying to tell you is that as soon as I stop running the game, whatever changes I've made to these settings is going to go away, and they're going to revert to whatever they were before. So if I set this to 2 and get it going a little bit faster, now I can press stop, and you'll notice that it goes back to 10. So the changes that you put in there are lost if you make the changes while things are running. So it lets you do this. It lets you go in and experiment and change settings and things like that, but you have to remember what they are. I recommend sometimes even screen shooting them or writing them down if it's an intricate set that you need to remember, and then once you click stop, all of your changes are going to go away. And this can really bite you if you do things like move things around and really change lots of settings, and you forget that while you're running, it's going to revert back to whatever its natural state is. So I'll click stop and take that back there. And so that is a pretty simple and straightforward demonstration of how we can add a script to pretty much any object in here.